I'm Anil Kumar, and in this series, we are going to discuss how to find general solution for trigonometric equations. We'll begin with the primary trigonometric ratios equal to 0 and move on to have different examples so that you get wide variety and understand the concept. My recommendation is that you should watch all these videos to get the whole concept. These videos are also designed for students who have just started trigonometry and also for students who are in grade 12. So let's find the general solution for the trigonometric ratios equal to 0. Sin x equals to 0. If you use calculator, you'll only get one value. Now to find general solution, we have different approaches. I will show you a couple of approaches in this particular video. So when we say sin x equals to 0, what do we mean? We mean that if we have a right triangle and sin x, as you know, is opposite over hypotenuse. Let me make one right triangle here. Sin x is, what is sin x? Let me write from very basic definition. It is opposite over hypotenuse in any right triangle, right? So where this angle is x, so sin x is opposite over hypotenuse. If I want sin x to be 0, that means I want this opposite side, which is along the y-axis, to be 0, correct? So if I'm moving along a circle with center at the origin, then you can see that the opposite side's length changes, and it is 0 only when it coincides with the x-axis, right? So these x-intercepts will give zeros for sin x. So therefore, we do find that the sin x is 0 when angle x is 0. For x-intercepts, angle x should be 0, correct? So we get sin x equals to 0, solution should be x equals to 0. Then when it goes through it, this is the position when x is 0. Here the x will be 180 degrees if you are talking about angle in degrees or pi in radius. So then we say, well, x will be 0, and then half circle it will be 0 at 180 degrees, and then when it comes back again 0 at 360 degrees, and so on, right? So what you notice here is that x is 0 for all multiples of 180. If you are working in radians, in that case x will be 0 at 0. Radio equivalent of 180 degrees is pi. For 360 degrees is 2 pi, right? So x is 0 for x equals to, the sin x is 0 for x equals to 0, pi or 2 pi. So general solution could be written as, for radians, let me write down the answer here now. For both radians and degrees, I will write down the answer. For x equals to n into 180 degrees, that is where n belongs to integers. Or we could write this as x equals to n pi, where n belongs to integers. Here, this answer is in radius. I hope you understand and appreciate it, right? Now let's follow the similar logic and find when is cos x equals to 0. Now cos x, as you know, is adjacent over hypotenuse. So if I sketch a right triangle, then cos x will be 0. This is adjacent over hypotenuse. That is cos x, right? So let me write down here cos x equals to adjacent over hypotenuse. Now if I want cos x to be 0, cos x equals to 0 means adjacent side is 0, right? Or at times when we are talking about the coordinate x and y, then adjacent side is x, right? So this x value is 0. Or we can say cos x equals to 0 when distance along the base is 0. Now that is only possible if the point is on the vertical axis, right there, or in the bottom. These are the two places, right? So for these two places, what is the angle x? For these two places, angle x is 90 degrees or 270 degrees, correct? So we get angle x is equals to 90 degrees or 270 degrees, and then again 270 plus 90, that is how we have to keep adding them up, right? In radians, it will be pi by 2, pi by 2, then this is pi by 2, this is 3 pi by 2, 5 pi by 2, and so on. So in general, we can say that the measurement of angle x, so I'm using different terminologies here so that it helps all of you, could be odd multiples of 90 degrees, which I could write as 2n plus 1 times 90 degrees, or I could write this as 2n plus 1 pi by 2 in radians, right? So that is how we can provide the answer for this particular question. Now let's look into tan, the other primary trigonometric ratio. In most of the videos, I will be dealing with sine and cos. Since tan is the ratio of sine and cos, we could actually get our results from them. Now in this particular video also, let me show you how. Tan x is equals to sine x over cos x. So if I say tan x is equals to 0, it means sine x equals to 0. Is that okay? Now sine x is 0 for these values. So our answer is that x is equals to 180n, where n belongs to integers. This is in degrees, or it could be n pi, where n belongs to integers, right? So that is how we can get solution for tan. Even if you consider the triangle, which we did consider for all of the cases. So what you'll find here is that tan is opposite over, tan is in any triangle, tan x is opposite over adjacent side, correct? So for tan to be 0, opposite side should be 0. Which is 0 at? X-intercepts. Do you see that? So the answer is similar to sine x. So I hope this logic helps you to first understand the concept and then to find out a general solution. Thank you and all the best.